watching this video. Please watch all the videos which I have shared for singly linked list, because we are going to follow exactly the same process. What we have done for implementation of singly linked list, we are going to learn for doubly linked list. So if we go with that video and come here, it will be very useful. Now here in this video, we are just going to create doubly linked list and display linked list. Okay, display that linked list, doubly linked list. Okay, uh, so our main function is going to use just two function calls, create and display. Here we are going to use again node for doubly linked list. We all know doubly linked list will have three members. One is data part, and we have two pointer variables, one pointing to the next and another pointer variable pointing to the previous pointer. So I'm including node struct star next and star previous to refer to previous pointer value and next pointer value. Okay, and here again we will have our starting node as null. Okay, start is equal to null. Okay, and then we'll be using new node. So start new node, and then for traversing we'll be using PTR. Okay, so PTR we are going to use. Now coming to create function, void create, open bracket, close bracket, open bracket. First thing is we have to get the number of nodes in the list. So printf within quotes, enter number of nodes in the list. Okay. Useless slash in semicolon. Then using a scanf function, we are going to get n. Okay, and again we are going to use a for loop for creating that n number of nodes. So I less than or equal to n, I plus plus will be using. So inside this for loop we are going to create a new node. So first we are going to create space for new node using malloc function. So struct node star ct struct node star malloc size of struct node. Okay, so we have created a new node. Next we need to get the value for that new node. So printf within quotes enter the value for new node, and that value we are going to get in another variable, say value. Okay, so we need to declare all those int I, n and value. So we have declared it. Okay, so we have created the new node and we have got the value. Now we need to assign new node data is equal to value and new node next as null and new node previous is also null. New node previous is also null. Okay, so with this we have created the new node from line number 22 to 27. We have created the new node, we have entered the value, and we have assigned the value in data part of the node, and we have made a new node next and previous node as null. Now, as usual, if this is going to be the first node we are creating, then obviously our start node will be equal to null. In this case, we'll just make our start is equal to new node. Okay, start is equal to new node. Otherwise, we have to use a pointer that starts from the starting node until it reaches the last node. So last node will be ptr next not equal to null, not equal to null only. Until the last node, we have to make a traversal from the first node till the last node. So ptr is equal to ptr next. We are traversing till the last node. Now this this while loop will, these three lines 33, 34 and 35 will start from the starting node and make this ptr pointer to point till the last node. Now we are at the last node. Okay. Now we have to make the adjustments accordingly. So what adjustments we have to make? We have to make ptr next to point to new node, right? And new node previous should be pointed to ptr, right? See, this alone will be performing in singly linked list. So ptr next will be pointing to new node, and this new node previous should point to the ptr. Whatever is pointed by the ptr value, that we need to point. Okay. By doing so, we have made the newly created node appended at the last node. Okay, as the last node. Now this for loop is over. For loop should end here, and after that this function should also end. Okay, this create function is over now. Okay, we'll remove all these extra brackets. Now we have to work with void display, right? Okay, so for displaying, again we have to take this. We have start from the starting node, and we have to display each node, right? So you printf %d comma ptr data. So you are printing every node data, and then you are moving to the next node. Okay, you are moving to the next node. This will happen inside this while loop. So please end this while loop after the statement. Okay, these both should happen inside this while loop. Okay, and here it's not null next. It should be ptr not equal to null. If you are doing this, then we should be able to display. I hope this works. Okay, there is a capital V. Okay, now run the code. Where is Y given? Okay, again capital V only given. Okay. Enter the number of nodes in the list, 3. Okay, 10, 20, 30. Okay, 10, 20, 30 gets displayed. We can redesign it. We can include some tab. We'll include some printf statement. What is that? Doubly link list. Okay, now you run and see. And this code 3, 10, 20, 30. See 10, 20, 30. See this display. See in doubly linked list, we can also print the list in the reverse order also with the help of previous pointer. That's not possible in singly linked list. You can try that and see how it works. Okay, we can go to the last node. Okay, and then we can print in the reverse order. Suppose, say for example, let me try. Okay, we'll use another function, reverse. Okay, see this is not possible in singly linked list, but in doubly linked list we can use this. Let me copy paste this code. Okay, reverse list. Okay, so we'll be moving till the end. Okay, first we have to make a traversal till the end. Okay, using this single line. Okay, now your pointer is in the last location, right? Okay. Now you use this while your ptr priv not equal to null. Okay, print within quotes percentage %t comma ptr data ptr equal to ptr priv. Now here also ptr not equal to null. Okay, only then it will be printed. See, if you print like this, we will use reverse. Okay, let me try whether this will work. Okay, now initially I'm starting from the first node, I'm traversing till the last node. Okay, so until the last node we are moving. So here we have to move until the last node. Okay, once we reach the last node, then we are printing backside. So ptr until not equal to null. So it will be pointing to the last node. So it's not equal to null now. So it will print the last node data. Then ptr will be moving to the previous node. So first starting node previous only will be null. So till then it will be moving. I think that should work. Okay, we'll try. Enter the number of nodes in the list. 3. Okay. 10, 20, 30. See, next I've created the list. Next I've called display and then reverse. So display will print doubly linked list 10, 20, 30 and 30, 10, 20 if it works fine. Oh, it's working fine. See, doubly linked list 10, 20, 30. Reverse doubly linked list 20, 30, 40. Here I have not given a tab. So this is what is the beauty of doubly linked list. This we cannot do in singly linked list. Okay. So we can reverse back, move from the forward till the reverse. Okay. So we'll rerun this code. Number of nodes to be created 5, let us assume 11, 22, 33, 44, 55. Oh, what happens? Let me rerun this code. 5, value of the node 11, 22, 33, 44, 55. So see, it is printed in the forward direction. It is also printed in the reverse direction. Okay. Now, as I taught you in singly linked list, try to convert this into a menu-driven program. I'll leave it as tutorial for you. So you please try to convert this into menu-driven program with create first choice, second choice display, third choice print in the reverse direction, and fourth one exit. Please try and see.